Good afternoon again, everyone. Welcome to another session hosted by the Ministry of Education Region 5 Mathematics team. I'm your presenter this afternoon, Itania Simpson, and with me is my colleague and co-host, Mr. Chevon Lewis. Now, students, I was about to say colleague. We're about to begin. So I'm asking just to look in the chat to see if everyone is here. Any of your friends are missing, just give them a nudge as tell them we are about to begin. Also, for the reminder for those persons who are just coming in, we are kindly asking that you tell us your school name, tell us where your school and your name. Also, we are asking that those persons who are using their devices, whatever devices, if it is not yet named, we're asking you to rename your device with your name so we can identify you a little better. Thanks much for hearing, understanding. We're looking forward to a great time. And also we are looking forward to persons, not misbehaving on the platform. I know you are good behaving boys and girls, so I'm looking forward to that. You will not be able to unmute yourself unless we ask you to. So you will have to get permission to unmute. So boys and girls, we're ready to... All right, so for today's session, materials that you will need, you just need most of you by now should have had the task given to you from your schools. If not, then grab your notebook, your pencil, and make sure you have an engaged mind ready to participate. Also, we're asking that when we ask for the responses, we will tell you when to talk, or we will ask you to just write in the chat. So we're asking you, boys and girls, to just be a bit obedient. Raise your hands when we ask you to, or just simply type in the chat. Okay, boys and girls, let's go. Now, today's session outline, we will solve a real-world problem that involves describing geometric patterns and making predictions for them. We're also going to be looking at identifying the mirror line as being a line of symmetry. We're also going to be looking at identifying and drawing the following polygons: triangles, square, irregular quadrilaterals, including the rectangle. Also, you're going to be required boys and girls, to read and interpret bar graphs. Now, with that said, and the final thing that you're required to do is use a grid of unit squares to find the area of any shape. Now, boys and girls, just quickly, and I often say to my students when I engage them face to face, when we ask these questions, these are some of the things that we expect you to ask yourselves in the exam. So if you see what it is that we're looking at, it says we're looking at geometric patterns, making prediction. I want just 2 persons or 3. Mr. Lewis, are you with me? To open their
I'm
mics
here.
and to just quickly tell me what they understand. So one person will tell me the first 2, another person will tell me the other 2, and then somebody else. So 3 persons quickly, just to tell us what they understand from the outline. What is it that we'll be doing? Anybody ready to participate?
Emily, you can go ahead and unmute your mic. Emily, you can go ahead and unmute your mic to share. All right, not hearing from Emily. I am not seeing.
All right, let me ask them to do something. Maybe they are shy, Mr. Lewis. So they can just type in the chat then to tell me what are some of the things that we'll be doing this afternoon. Just type it quickly in the chat. Any responses so far?
No responses as yet. Well, somebody said mathematics, preparation for PEP, mathematics.
So based on the outline, boys and girls, what are some of the topics we'll be looking at in our presentation today?
Seeing line segments,
Okay.
geometric shapes, problem solving,
Mm-hmm.
geometric patterns, algebra, line of symmetry fractions,
All right. Okay, boys and girls. And
finding
yes,
area,
right. And yes, I left off the last one, which says adding fractions with like denominators. All right, boys and girls, thank you for that. And we are moving right into our sample performance task. Now, today we're going to be looking at the recreational park. And it reads as follows. The Citizens Association of your community wants to redesign the space for the recreational park. The current design has several walkways that lead to different facilities in the park. It also has 2 rectangular sections, one for the common playground and the other for the children's playground. Now, boys and girls, before I even go any further, here's another chance for you to communicate with me. We're talking about a recreational park. Can I get another name for recreational park? What other name can I use instead of saying recreational park? Or even before I go to that, recreational park, what do you think happens there? Just type in the chat.
I'm seeing
Anything?
playground,
Yes.
playing, theme park,
All
creating
right.
memories, exciting things, people play there, fun
All right.
activities, relaxation, exercising, and the list goes on.
And the list goes on. Thank you, boys and girls. And you are indeed correct. You know, another name that we can use instead of saying recreational park, we can say the playground. And so it is that you are required to create. You know, we're going to be designing and we're going to be looking at the current system and see what is happening here. Let's continue. As a member of the committee, boys and girls, your task is to, 1, you're going to be using the geometric patterns for the current walkways to create similar designs for other walkways. 2, you're going to make the requested change to the common playground. 3, you're going to interpret the results of the survey conducted by the Citizens Association. And 4, you're going to use the results of the survey to do the design of the new children's playground. So we have, how many tasks do we have aligned for us, boys and girls? How many parts of the task? Come on,
You're
boys
saying
and girls.
4.
Very good. So we have 4 different tasks for us to do. So let's get the ball rolling, boys and girls. Now, part A says, the main walkway along the horizontal is made up of rectangular and triangular bricks. Other paths that lead to different parts of the park intersect the main walkway at right angles. All of them are designed using the same pattern. A few walkways are shown. However, shapes 1 and 5 are incomplete. Examine shapes 2, 3, and 4. And then, after examining shapes 2, 3, and 4, boys and girls, you are now required to use your grid to complete shape 1 that leads to the restroom and shape 5 that leads to the entrance of the common playground. So, boys and girls, let us look at our shape. Let us look at our grid. What do you notice about shapes 2, shape 3, and shapes 4? What do you notice about them? What is common about these shapes? Type in the chat for me, what do you notice? What's common about them?
I'm seeing persons saying that it gets bigger. It's shaded. They are the same shapes, just different size. They're shaded, longer. They have half of a corner, different size. You add 1 each time.
All right. Okay, boys and girls, good job. So you're seeing. Now, what a lot apart from the fact that the shape's getting bigger, how many, let me ask some specific questions now. How many squares do we see? Oh, before I go there, are all the squares in the same direction? Are the squares going in the same direction? I see Sian hands up. Sian Walker's hand is up.
All right, so in the chat they were saying yes.
All the squares are going in the same direction. Boys and girls, look at the square.
I'm
Look at the
seeing
shapes
no
for me.
for some person.
All right, I just want to pause here again to remind the persons on the platform to rename your device. I'm seeing Fire Tablet. I'm seeing Motorola Motor. I cannot call those names. If you want me to recognize you, you have to rename your device. So we're asking you again to just pause, boys and girls, and to rename your device. Thank you so much. All right, so Mr. Lewis, they answered to say no. Can they
I'm
tell me
seeing one person saying horizontal.
very good. So one of the directions would have been horizontally. And what about the other one? Since they're not going in the same direction, what would be the other direction?
I'm seeing vertically.
Horizontal, right. So you have some of the shapes going in horizontal direction. And persons, boys and girls, If you want to say they are going across left to right, that's not a problem. If you want to say that they are going down, that's not a problem. Vertical going down. So we just want you to be specific with the directions. So let me ask you the question. Let's look back at shape 2. How many squares are go in the horizontal direction for shape 2? How many squares?
All right, so I'm seeing two, 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 two
All right,
blazing up the chat.
good job. What about vertical? How many shapes? How many squares, boys and girls, are in the vertical direction?
Still saying two,
All right, good job.
all the
So
way.
then, if we look at shape 3, how many squares do we have going horizontal and how many do we have vertical?
I'm saying three. Most persons are saying three.
All right, good job. You're on the ball. Now, what can we say about shape 4 then? How many squares are going across?
I'm seeing four.
All right. And we have 4 going down. Now, which shape, boys and girls, is constant? Which shape is constant? Which shape is constant? And what do I mean by constant? Which shape are we seeing? Which
I'm
shape
seeing
does
somebody
not?
saying the triangle.
The triangle. So all of the shapes, the triangle must be a part of the shapes. All of them. So it is then, boys and girls, we would have started shape 1. What did we start shape 1 with? What did we start shape 1 with? Just type your answers in the chat. What did we start shape 1 with?
Most persons are saying square.
All right, good job. So we started with the square. What will come next in shape 1? What will come next in shape 1?
The persons have a mix of square and the triangle.
All right, boys and girls, so let's explore this a little bit more. If it is that we have, let's look back at shape 2. How many triangles do we, sorry, how many squares do we have going across in shape 2? I'm seeing 2 persons are responding. 2 squares, you are correct. So it is how many squares going across in shape 3? And persons are responding again by saying 3. What about shape 4? So then, how many squares would be going across in shape 1? How many squares would be going across in shape 1?
I'm seeing one.
All right. So do we have that 1 square already, boys and girls? Can we see that 1 square already? Or do I
They're
need to
saying
draw?
yes.
All right. So since I have my square, what would be the next shape in that pattern? What would be the next shape? Look back on
Triangle.
all. All right. And where would the triangle go? Would it go to the left of the square or to the right of the square? Where would I place my triangle? To the left of the square or to the right of the square?
Persons are saying right,
All
mainly.
right.
Have a few persons
So
saying left.
let's see if you're correct, boys and girls. All right. So there is my triangle. What next will come in my pattern? What next? What's the next shape?
Persons are saying square.
Where will I place the square? Where
The
will I
square
place?
down.
Is it below the
Square
square or
below.
below the triangle? Below the square or below the triangle?
Persons are saying below the other square. Below the triangle. Responses are mixed.
All right, so boys and girls, let's look back on shape 2. Let's look at shape 3. Where are the squares placed? Are they placed below the other squares or are they placed below the triangle? Where are the other squares placed?
They're now saying below the triangle.
All right, so it is going to be below the triangle. So we have completed shape 1. We have shape 2, shape 3, shape 4. Those are completed. Now we have to complete shape 2. Sorry, shape 5. Now we have to complete shape 5. So boys and girls, how many squares will make up shape 5? How many squares will make up shape 5? You can give me the total number of squares in shape 5, and then you can be specific about where the squares go. How many squares will be in shape 5?
So they're saying 10 squares in shape 5. Some persons are saying 5 and 5. They're saying it needs 4 more.
All
5
right.
across, 5 down.
All right. That's what I want to hear. So we need 5 going across and 5 going down. Now, we already have 1 square. Do I need to add 5 more? How many more squares do I need to add since I already have 1? How many more squares do I need to add since I
They're saying
already have
4
1?
across.
All right. So yes, boys and girls, 4. Let's see where we're going to add it. All right. Do we have 5 squares? Now, what is my next shape? I have 5 squares. What will be the next shape?
They're saying triangle.
All right.
Triangle is based on the chat.
All right. You're correct, boys and girls. Now, which direction am I going to go again? Am I going horizontally or vertically? Which direction?
I'm saying vertically.
And home, good. All right. How
Down.
many? Down vertically. All right. How many squares do I need to add going down or vertical in the vertical direction?
They're all saying 5.
All right. Good job, boys and girls. And this is what the completed shape will look like with the squares added. Good job. So, boys and girls, we have completed the first section of part A. Let's continue to see what else do we need to do. Now, part B says, shape 9 is the walkway that leads to the snap joint. Snap joint, Mr. Lewis. Boys and girls, I wonder if you know, or you can give me another name for snap joint. I don't think Mr. Lewis knows. Let's help him to understand. Another name for snap joint.
I'm
Any,
seeing tuck shop, cafeteria,
oh, wow. Big
tuck
names.
shop.
All right. So boys and girls, you do know. So it is that shape 9 is the walkway to the snap joint. Based on the design of the other shapes, how many squares and triangles would this walkway have? Now, let us use a table, boys and girls, to help us to understand this question. How many squares and triangles would this walkway have?
I am seeing person saying 18 squares and one triangle.
18. Will all the squares be in the same position? Will all the
Saying
squares be in
no.
this? Okay, so I want you to share it up for me.
So it's a 9 horizontal, 9 vertical,
All right.
9 across, 9 down.
All right. So let's see if the boys and girls, let's help some other boys and girls to understand what is happening. If you look at shape, let's look back at shape number 1. How many squares do we have going across? Or how many squares do we have horizontally?
They're saying 1, 1.
All right. So you're correct. What about vertical? Oh, they put all of them in the chat. All right. So you're saying 1 across and 1 down. For shape number 2, how many squares do we have?
You're saying 2,
All right.
2,
Good job. And how many do we have going down, boys and girls?
2.
All right. Come on. Let's see for shape 3. So let's just complete the table. How many squares would be there for shape 3?
You're saying 3, 3, 3, 3, 3.
All right. Shape 4.
Saying 4, 4.
All right. And for shape 5.
You're saying 5, 5.
So, boys and girls, let me ask you something. How many squares would we have for the 6th shape? How many squares would we have for the 6th shape?
You're saying 6, 6, 6.
All right. All right. So you're on the ball. Well, now that you can tell me that, can you now tell me then, boys and girls, how many squares would we have for the 9th shape?
They're saying 9, 9, 9, 9,
And
9.
that is correct. Good job, boys and girls. So, in answering question B or part B of question 1, we can say then that we would have 9 squares horizontally, 9 squares vertically, and we would have our 1 triangle. So we have 9 squares horizontally, 9 squares vertically, and our 1 triangle. All right, boys and girls, good job. Let's continue. Now, I want you boys and girls to state a rule that is used to create the shapes. If we look at shape 1, what would we have done to end up with 1 square? Could we have done to 1 to end up with 1 square horizontally? We have shape 1, 1 square. Shape 2, 2 squares. Shape 3, 3 squares. What could we have done to end up with 1 square? 1 shape, 1 square.
We're saying count adding one,
Count adding one.
going
All
up by
right.
one.
All right. Now, boys and girls, if we were to look at the shape number, if we are to look at the shape number and the horizontal squares, what relation, what do you think we would have done to the shape number to end up with the horizontal squares? We have shape one horizontal square. Shape two horizontal squares. What do you think we would have done to shape one to end up with one horizontal square? Anything,
Right, so
Mr.
in the
Lewis?
chat, they're saying add one each time. Add one. I'm just seeing add one each time by adding one.
Okay. But
So
boys
one
and
plus
girls,
one.
if we were to add one each time, let's say, let's look back at, let me go back to this shape. If we were to add one each time, if we were to add one to shape number 1 plus 1, would 1 plus 1 give us 1? Would 1 plus 1 give us 1?
They're saying no.
Okay, so what could we do to 1 to end up back with 1 as our answer?
You multiply.
All right, we could multiply.
Multiply by one.
So if we multiply shape 1 by 1, we would get 1, right? 1 square needed, don't it? What if we should multiply shape 2 by 1? How many squares would we get? What is 2 times 1?
They're saying two.
What is 3 times 1?
Three.
All right. So what if I should ask you then, how many squares would be in the 10th shape? How would you come up with that answer? Horizontally, we are talking.
They're saying 10.
All right. Now, how many squares would be in the nth shape? N meaning that n can be anything. And I know you guys do a little bit of algebra. So n can be anything. How many squares would be in the nth shape? That shape, if I should say to you, all right, let's take n to be 20. How would we know how many squares would be in that shape? What would we do? Because we decided that we're going to be multiplying by 1.
They're saying n times 20. Multiply 5 times 1, n times 20. 10
And
plus 20, n times 20.
all right, so boys and girls, let's go back. Remember, the shape number, we're talking about the shape number. What did we multiply 9 by to end up with 9 squares horizontally? What did we multiply by?
They're saying 1.
So what would we multiply the nth shape by to end up with the answer?
They're saying n times 1.
N times 1. And would it be the same thing for the number of squares vertically, boys and girls? Would it be the
They're
same
saying
thing?
yes.
Good job. Good job. It would be the same thing. All right, so this is what we have. So horizontal squares, n times 1, and our vertical squares, n times 1. Good job, boys and girls. We are moving on. So now we would have completed part A of our task. Let's move on, boys and girls. And for some of you in your grid, you can use your grid. We're not going to be doing that today, but you could, if you want, you can design your shape 9. You can draw shape 9. This is what shape 9 would look like. After deciding how many squares it would have, this is what shape 9 would look like if you decide to draw. All right, so let's move on to part A. Sorry, part B. And part B, the heading on part B is the common playground. The diagram above shows the common playground in the park. It has 2 triangular sections for exercise, and the other part is a grass section for picnics. Are we seeing that, boys and girls? Can we see the triangles?
They're responding yes in the chat.
All right, good. That's good. All right, boys and girls. Now, let's continue. Your task is to write the word picnic in the picnic section and the letter E in the exercise sections on the grid above. Now, where would I write the word picnic? Where would I write the word picnic?
They're sharing in the middle, in the green part, the green area, the middle.
All
They're
right.
saying E at the left, E at the right, and the middle, picnic.
All right. All right. No problem. But before I even write that, though, boys and girls, can anybody tell me how many sides does the shape in the middle or the green area have?
It's a mix. Some persons are saying 4, most persons are saying 3.
Look at it again, boys and girls. Look at it again.
Right. 4 is more frequent now. Persons are saying 3 or 4, they're not sure.
All right. So let's see if we can highlight. So boys and girls, are you seeing my highlight? I'm going across, going across. Are you seeing me? So that would be one side. Let's find the next side. Let's find the next side. Let's find the next side. All right, that's 2 sides. Oh, forgive my shaky hands, boys and girls. So how many sides are you seeing now?
They're saying 4.
All right, good job, boys and girls. All right, so boys and girls, let's continue. Where would I place the word picnic again?
They're sharing in the middle, the green
Oh,
middle, to be more specific. In the
all
middle, the
right.
green in the middle.
Okay, good job. You are all correct. So we will place the word picnic right there. Now, where would we place the letter E? How many triangles do we see, by the way?
They're saying E, put E in the 2 triangles.
Oh, wow, they're already ahead of me. Put E in the 2 triangles. All right, boys and girls, good job. And you are indeed correct. Now, boys and girls, next question. What type of quadrilateral is the picnic section? What type of quadrilateral is the picnic section?
They're saying, so I'm seeing trapezoid, trapezium, rhombus, triangle,
No, let's
trapezium,
go back. Hold on,
trapezoid.
stop. Stop, Mr. Lewis. I want to, the person who said triangle. Let's remember how many sides does the green area have again? And remember the word quadrilateral. What does quadrilateral mean? How many sides? Once it's a quadrilateral, how many sides?
They're saying 4.
Yes, so boys and girls, if it is a four-sided figure, can it be a triangle? If it's a
They're saying
four-sided
no.
figure, okay. So let's go
Triangle
back
has
to the
3 sides.
right. Good job. So what is the name of this quadrilateral then?
Trapezoid,
All right.
trapezium,
Trapezium.
rectangle, trapezoid, rhombus, trapezoid. Trapezoid and trapezium are dominating the chat.
And they are correct. So the name of this quadrilateral is it's a trapezium. All right, boys and girls. We have another question.
Just a point to note, Miss Simpson.
Yes.
So trapezium is the same as the trapezoid. Because some persons wrote trapezoid.
All right. Okay, boys and girls. And one, I think trapezium. We're both familiar with both of them, but we use trapezium under the whole British and the English language. Trapezoid would come from the Americans, but anyone you write would be accepted and will be correct. So not a problem. All right. So let's look at the last task under 2A. It wants you to tell me how many square units does the entire common playground cover? How many square units does the entire common playground cover? And before you even, I want you to also explain
Uh,
how you would
they're
arrive
ahead
at
of
the
you, Miss.
answer. They're giving me already, Mr. Lewis?
Yes, they're all saying 60.
All right. All right. One person can tell me what they would. I just want two persons to give me two different. One person can tell me how they arrived at the answer. One person, Mister, just allow one person to quickly unmute and explain how they arrived at the answer.
All right, so I am seeing Sian, you want to share? You can go ahead and unmute, walk on that is.
Um, I would say 5 times 12, you go 12 across and 5 down. That's how I got the 60.
What did he say, Miss? I didn't hear. Go again. Can you repeat?
Repeat, Sian. All right, so I think he said that he did 12 across and 5 down.
So he multiplied.
Yes. He's saying yes.
All right. Somebody else tell me if you did something different.
All right. Is this Jatia? All right. She had, well, here she had something in the chat.
What are they saying, Mr.
Let's
Lewis?
hear from Britty. Well, gone. Tyler Williams, you can go ahead and unmute. Tyler, you can unmute to share. All right,
I
not
add
hearing
up
from Tyler. Go ahead, Tyler.
I add up all the squares
All right.
or
All right, thank you. So he would count all the squares. So it doesn't matter how you did it. Some persons may decide to count all the squares. Some persons may decide to use the row by column method. So they would multiply 12 by 5 and they would end up with 60. So whatever you did, your answer would be 60 square units. All right, good job, boys and girls. We're moving on quite nicely. So let's continue. We have to mute back that person. To allow older and younger children to play safely, the Citizens Association requested that the playground have 2 separate sections that are symmetrical to each other. Draw a broken line on the diagram to show where the playground would be separated. All right, boys and girls. So I want you now to tell me where on my diagram would I place my broken line?
They're saying draw it in the middle, cut it in half, in the middle, the middle.
And what
Right,
does
I'm
it,
seeing a me. Let me go up and see who is the me. So they say in the middle.
all right,
Both
in the
friends are
middle.
saying in the middle. Horizontally.
Horizontally in the middle? Are you sure it should be horizontal? Before I even put on my line, what does it mean when something is symmetrical? How do you know that something is symmetrical?
Not getting any response yet. It is, so it's cut in half, can go in half because there's a mirror line, a straight line. Both sides are the same. It
Okay,
is the
boys and
same
girls.
size.
All right. Now, if both sides are the same, there is this word that you learned in school that tells you or describes when 2 items are the same or 2 shapes are the same size and everything. What word is that? What could we use to describe objects of the same size and shape? We can say that
Identical,
they're
congruent,
congruent
congruent,
or
similar,
very, very good. So
equivalent,
if I were
symmetrical.
to, good job, good job. If I were to place my broken line horizontally, will I have 2 congruent shapes, boys and girls?
They're saying no.
All right, so can you tell me where to place my line? Which direction?
They're saying vertical, down.
Vertically. All right. So, boys and girls, you are correct. And that is where I would place my broken line. Now, boys and girls, what name is given to the broken line that was inserted? What name is given to that line?
They're saying line of symmetry, mirror line. Line of symmetry, mirror
All
line.
right. All right. So that is correct. I see that coming up for true. Good job, boys and girls. So mirror line or line of symmetry. Now, boys and girls, let me ask you a question. If I were to place the broken line horizontally, I'm showing you, can we still say that these shapes would be congruent or equal or similar? Just reinforcing.
They're saying yes. Some persons are saying no.
All right. Now, boys and girls, good job. We have completed part A and part C. Only two more parts to go. And we'll hand over now to Mr. Lewis. Take it away.
All right, boys and girls, you have been doing well so far. So let's continue. So we're now at part C of the task, which reads selecting equipment for, so part C looks at us selecting equipment for the children's activity. Now, a survey was conducted with some children who use the playground frequently to determine the activities most liked by them. The bar graph below shows the results. So let's talk a little bit about the bar graph below. So can you tell me what are the activities that are displayed on the bar graph? What are the activities that are displayed on the bar graph?
I'm seeing seesaw. I'm see only seesaw so far. Swing, slide, seesaw, swing and slide, monkey bars.
All right, great. What's the scale? What scale is used on the bar graph? What are they counting by?
I am seeing 2 dominate in the chat, counting by 2.
Interesting. So let's continue. So we observe that they're counting by 2. We observe all the activities that are a part of the survey. Now, boys and girls, how many children like the swing? How many children like the swing? So based on the graph, the bar graph, how many children like swing?
I'm seeing 9 and 10, 9, 10 dominating, 9, 10. Some persons 9, 9, 9.
All right, so we see 9 most frequently or 10. Mr. Simpson, we're seeing 9 most frequently or 10.
No, how many children like the swing is 9.
Okay, great. How did we get 9? And we're not seeing 9 on the bar graph, on the scale. Can anybody open your mic and share with me how you got to 9?
Let me look for who would have raised their hands. Just a minute, mister. Let's look at Abigail. Let's ask Abigail to unmute. Abigail. Abigail, you can go ahead and yes.
It's because it is in the middle of 8 and 10.
All right, interesting. And what number falls in the middle or between 8 and 10? Which whole number falls
That is
between
9.
8 and 10? That
It
is
is 9.
9. Excellent job. So if we needed to find out how many students like seesaw, what would that number be? Post the answer in the chat.
Lord.
Any responses yet in the chat, Mr. Simpson?
Not seeing anything yet, Mr. Lewis. I am seeing person saying 3, 3, 3, 3, 3. 3. That's dominating the chat.
Excellent job, boys and girls. It is indeed 3. So we have 9 students who like the swing. Let's continue. What is the most liked activity?
They are ahead of
What
you,
is the
Mr. Lewis.
most liked activity? Okay, let's
They have
hear it.
started to share slide. Everyone, slide is dominating the chat.
All right. And how do we know that? Could somebody just open your mic quickly and share? Anybody? You're unmuting anybody, Mrs. Simpson?
I am finding someone else. Kiara. I'm asking Kiara to unmute. Kiara. Kiara seems shy. What about Sian? Sian Walker can unmute.
Okay, so I say 10 because 10 is the highest number and slide is currently at 10. So that is my explanation.
Excellent. Good explanation. So it is indeed 10. Now I have another question for you. Now, based on this bar graph, how many children were surveyed? Based on this bar graph, how many children were surveyed? They're posting the answers in
30.
the chat here, Ms.
Yes,
Simpson?
yes, sir. 30 is dominating the chat. 30 all the way.
Excellent.
30, 30, 30.
Wonderful. So a total of 30 children were surveyed. Now, let's continue. So here we are. Let's try to figure out, looking at our graph, which is to the right of your screen. Let's get it. Use information from the bar chart, complete the table below. Now, how many children, what's the number of children who liked seesaw? So let's complete the table quickly. Let's post in the chat how many students would have
3,
liked
3 is the
seesaw.
dominant answer. 3, 3, 3 all the way.
3 is
3 all the
correct.
way.
Let's move to slide. How many students like slide?
10 all the way. 10 all the way.
And you are correct. How many students like the monkey bar?
8, 8, 8. 8
Good
dominating.
job.
8
You're on the
dominating.
ball, boys and girls. Now let's go to the swing. How many students like swing? How many children like the swing?
9 is dominating the chat.
9. Excellent. Now, can somebody quickly calculate all these number of children that we have here for the different activities and tell me what is the total number of children?
They're saying 30 all the way. 30 all the way.
Excellent. I would have said that before, that a total of 30 students were surveyed. Now, let's look at it. What fraction would seesaw represent?
Seeing 3/10. 3/10.
Are we sure that seesaw will be 310? What's the whole? What's the denominator? Which of these numbers would we use as a denominator?
They have changed it. They have changed it to 3/30th. Somebody said
All
3/30th or 1/10. 3/30th or 1/10. 3/30th is dominating the chat.
Excellent. 3/30th, or if you have 1/10, you are indeed correct as well. Let's look at slide as a fraction of the total number of students.
10/30th is dominating the chat. 10/30th.
Can we write that another way? Can we write that as a reduced fraction?
1/3. 1/3.
Excellent. Good job, boys and girls. Let's look at the monkey bar. What fraction would that represent?
Seen 8/30th. 8/30th. That's
And
dominating.
and in its reduced form, it would be anybody got that one, Miss Simpson?
No, not yet. They're still writing it as the original fraction. I'm seeing 2/15. 2/15.
All right. So we need to check that again. Would it be 250?
Somebody has the correct one, 4/15. Neymar
415
says 4/15.
is correct. Now let's
Alexandria,
move on.
Abigail, 4/15. So they're on the ball. Bethany, 4/15.
Good job. So let's look at swing. What fraction would that represent?
9/30th. They're ahead of you, Mr. Lewis. 9/30th.
Or how else can we represent it in its reduced form? Anybody got that one?
3/10. Amari says 3/10.
Excellent. So that would have been 3/10. Good job, boys and girls. So, what is the sample size of the survey? What is the sample size of the survey?
They're ahead of you. They have 30. We can't trick them at all. 30 is
Not
their
at
answer.
all.
30
Correct.
is their answer,
Very
Mr.
good.
Lewis.
So the sample size is 30. Very good, boys and girls. So we're on now to our last section. Now, this section requires you to design the design of a space for the children's playground. The rectangular space for the children's playground is to be the same area as the space for the common playground in part B. It will be divided into the following smaller geometric shapes for each activity. Triangle for the seesaw, rectangle for the slide, square for the monkey bar, and trapezium for the swing. Now, can anybody recall, type in the chat quickly, what was the area of the common playground in part B?
Oh, yes, Neymar is on par. He says 60. But the leaving of the units, the square units, they just have 60. Something is missing. But everybody has 60, Mr. Lewis.
All right, good job. So it is 60
Squared units.
60 squared units. So, point to note. Let's look at the shape that was there originally in part B. And can anyone tell me what you notice about the space that is outlined? The three shapes that are used. What did it do to the space that is outlined?
Not seeing a response yet.
Was there any space left?
No. They're saying no, 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 no.
All right, excellent. So we'd have noticed that the triangles and the trapezium would have covered the entire common playground. Now, this is a point important information to note. The triangle, rectangle, square, and trapezium use up all the space inside the larger rectangle. So when we are creating our shape, these must use up all the space in the rectangle. Now, let's go, boys and girls. So the rectangle's dimension should be either 4 units by 15 units or 6 units by 10 units. So for here, boys and girls, we might have different units. So I want you to post in the chat which unit you prefer to use quickly. Did they share, miss?
I see 10, 6 by 10. Most persons are choosing 6 by 10. Most persons are choosing 6 by 10.
So if it's 6 by 10, what shape would the outline for the playground be? What shape for the
I'm seeing
outline for the
rectangle,
playground?
rectangle, rectangle. But
Would the
I'm
shape
it.
change if we use a 4 by 15?
No, I'm seeing no. It would still be rectangle, rectangle coming up.
Excellent job, boys and girls. So we're going to use the grid to to draw the rectangle you chose. And so we had to choose a rectangle. And so we're going to show a display of a few of the rectangles. So here is our first rectangle. Can anyone tell me the width of the rectangle? And what is the length of the rectangle? This purple
I'm seeing
rectangle that is displayed, what's the width and what is the length?
I'm seeing 4 as the width, and I'm seeing 4 for width, 4, 4, 4, 4 dominating the chat.
And the length is?
I'm seeing 10. But somebody changed it to 15. 15.
All right. Excellent job, boys and girls. It is a 4 by 15. So can you tell me what is the area that this rectangle covers? Anybody got it yet?
60, 60, 60, 60.
Excellent. So that means that this representation would fit. So it's indeed a 4 by 15. Let's look at another orientation. Can anyone tell me what is the length and what is the width of the second rectangle?
Uh,
Anybody sharing it?
no, not yet. I'm seeing 4. I'm seeing 4. Somebody's saying it's the same thing.
Excellent, boys and girls. It's indeed the same thing. It's still a 4 by 15, just a different orientation. So for those of you now who have chosen another dimension for your rectangle, can anyone look at the red rectangle and tell me what's the dimensions for the red rectangle? What is the dimension? What are the dimensions for the red rectangle?
6 by 10. 6 by 10. 6 by 10. That's what is coming up. 6 by 10.
Great. Now, can you tell me what is the area that the red rectangle covers?
60. 60 is dominating the chat. 60 is dominating the chat.
Excellent. Good job, boys and girls. Now, is there another way that you think we could have turned this rectangle? Or this is the only way we can turn a 6 by 10 rectangle?
They're saying yes. There's another way. Yes. Yes.
All right.
They're saying horizontally.
Excellent. So we can also turn it horizontally. I would have end up with the same area, same dimensions. Very good, boys and girls. Now we want to look at designing the design of our playground. So now that we're at this stage, let us look at how we can design our playground. Now, boys and girls, what was that critical information that we shared earlier about the shapes? The shape should. Can anyone open your mic and share with me? Anyone willing to share it, Miss Simpson?
I'm looking for the yes. Leo. We're asking Leo to unmute. Leo.
Yeah.
Go ahead, Leo. What did we say about the shape and this playground? What was that information? We should ensure that the shapes do what?
Yeah, different
Yes, they are different, but all the shapes should take up what?
space.
The space of the playground. Good job, Leo. So now, I want you to work with me in the chat now. So if we decide to put our monkey bar in, what shape should our monkey bar be? What shape should our monkey bar be?
All right. I'm seeing rectangular. Rectangle, rectangle, rectangle.
Are we sure the monkey bar is supposed to be rectangle or something else should be rectangle?
They have changed. They have changed to
They have
square. I'm
changed
seeing
to.
square, square, square.
All right, excellent. So now, our monkey bar is supposed to be a square. Can somebody give me a dimension that we can use for the monkey bar? Or tell me the area that the monkey bar would take up. The suggested area we want the monkey bar to take up. Anyone?
4 by 4. I'm seeing four
The rest,
units.
I'll say 4 units.
Yes.
So do what? 4 units across. All right, so let's go. There are 4 units. Forgive my shaky hand. And I'm going to write MB for monkey bar. All right, so that's our monkey bar. Now, which other activity do we want to fit in? So the monkey bar is a square. What else do we want to fit in?
Somebody said slide.
The slide. All right. Can you give me the dimension that you want to use for the slide? Or tell me how many square units the slide would cover?
They're saying 10. They're saying 10.
All right, 10. So so you have to give me some direction now as to where to place it. Do I go beside the monkey bar or do I go above the monkey bar? So where are we taking the 10 from?
They're saying above, over the monkey bar, above.
All right. So let's see if we can find that as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So do I do one row of 10 or do I do two rows of 5?
Two.
All right, so let's go. So I'm gonna write S for my slide. All right, so the slide is right there. Now, what else do we need to add to our playground?
Swings, seesaw and swings.
All right, so which one we putting in first?
They said swings.
All right, so let's look at the swings. How many square units should the swing take up?
They're saying three.
3 square units? Only 3?
They're saying 3 by 3. 3 by 3.
If we're talking about a 3 by 3 dimension, what shape would that be? If all sides are equal, what shape would that be?
They're saying square.
Is it a square that we're supposed to have for this swing? What's the name of the shape for this swing? What's the name of the shape for this swing?
Trapezium.
All right. So let's see if we can draw a trapezium. So I'm going to take it from beside the slide down. My hands are shaking. All right, so let's go across. So here is the outline. So here's the first outline. And so because I have one side here, this is one side, and I have one side down here, one side to here. Let's see if we can get a trapezium if I cut it like this. Would that give me 4 sides? Boys and girls, would that give me 4
I've
sides?
seen no, yes. Most persons are saying no.
All right, that would not have given me 4 sides. That means I cannot cut it there. So let's find a place to cut it. So where can I cut it in order to get a trapezium? All right, so let's cut from this end. Right here. Now, is that a trapezium?
They're saying yes.
All right. So can we then get a triangle to take up the entire space? So the other shape, is the other shape a triangle? Is the other shape a triangle?
They're saying yes.
Are we sure it's a triangle? Look at it. How many sides does it have? One side towards the monkey bar, another side at the bottom, and then you have the slant line going up to create the trapezium. And then there is a little line right here. So that's 4 sides. So how can we adjust this so that we have only 3 sides? What can we change? What can we change? Which one of these can we change?
You're saying the little line.
So we're gonna change that little line.
They said move the slanted line.
Mm-hmm. And so do I need to extend my slide? All right, let's go, boys and girls. Let's extend the slide. Let's carry the slide all the way out. That's my slide going all the way out. And let's see if we can get a trapezium now. Cutting it from there right down. Do I have a trapezium?
Yes.
Do I have a triangle?
Yes.
All right. Excellent. So this is one possible design. So the trapezium would represent our swing. So let's write SW for our swing. And then SS for our seesaw. So this is one orientation. So let's see if we can look at some other orientations. So still using our 6x10, and we want to put our slide. So they have the slide, we have the slide at the bottom. Then we put in our monkey bar right above that. Then we would have when we put in our monkey bar and our slide, what shape do we have left? The area that is left without being identified is in the shape of what?
I'm seeing
So looking at
rectangle.
this area,
I'm seeing
rectangle,
rectangle,
excellent.
rectangle, rectangle.
All right. So let's look. So we have a rectangle remaining. So let's continue. Now my triangle is in. Can we identify the trapezium?
Yes, yes.
All right. Tell me what the color lines are that create the trapezium.
Red. I'm seeing red. Red. Red,
Just
blue.
one color?
I'm
Red,
seeing red,
blue,
blue, orange. Red, blue, green. Red, blue, orange, green.
red, blue, orange, green. Excellent. So here would be our seesaw, and here would be our swing. Excellent job, boys and girls. Let's look at another orientation using our 4x15. So for those who chose 4x15, here's another orientation. So here we have our slide, which is 4x5. So we're gonna fill in our monkey bar, which is a 4x4. And then we're filling in our triangle. And then what remains would be our trapezium. Looking at another orientation, there we have our slide. We have our monkey bar right there. We have our Swiss seesaw with our triangle. And then we have our swing. Now, boys and girls, now to 4D. Question 4D. So you're asked to count the number of squares that each shape takes up and then use. So we're counting the number of squares that each should take up and use the information to complete the table below. Now, let's look at one of the orientation that we have. Let's look at this orientation. Now, based on this orientation, can you tell me the number of squares that the seesaw takes up?
I'm seeing 5, 5, 6.
All right, so saying 5 or 6. So it is 6. Good job. Now, what fraction? What would be the fraction of the total area?
I'm seeing 660. Yes. 668, 668 or 1/6.
All right, so good job. Now let's look at
And there are persons, sorry, Mr. Lewis, there are persons saying 1/6, but it can't be 1/6. If 6 is the factor, then how many, when we divide 6 into 60, what will the, right? So Neymar has corrected to say it's 1/10.
good job, Neymar. So that's 660th or 110. Now for the slide, let's look at the slide. How many squares does the slide cover? How many square units does the slide cover? Any response yet?
I'm seeing 20, 20, 20 dominating 20.
Excellent, good job. What fraction would it be in terms of
20/60th,
the total area?
20/60th,
20/60th or
yes, or 1/3.
1/3? Excellent. Let's quickly go to the monkey bar. How many squares does the monkey bar take up?
Um, 16, 16, 16, dominating 16,
Good job, boys and girls. And what would be the fractional value?
16/60th.
Great job. What about the trapezium, the swing? Any response yet for the
I'm seeing
trapezium?
18, 18.
Excellent job, boys and girls. What fractional value?
I'm seeing 18/60th. 18/60th. That's dominating the chat.
Good job, boys and girls. Well done. Excellent job. So let's look at a different orientation for those who have used the 4 by 15 orientation for 6 by 10. So let's look at this orientation and let's see, as we talk about the seesaw, how many squares does the seesaw take up in this orientation?
I'm seeing 4, 8. This one I'm seeing up to 11.
All right, so what's the dominant one?
9. 9. 9 no.
So let's go. So that's 1, that's 2, that's 3, 4, 5, 6, 7. That's 7. So we're gonna fit now to see if we can fit portion. So this is the part gonna fit up here, which is gonna make 8. And then we have another little part. This little part is gonna fit here, which is going to make 10. All right, no, 9. And then we have this part here. So this part and this is the part here. So it seems that they are correct, Miss Simpson.
Yes. Yes, they are.
All right, so the fractional value of it, so it would have been 11 in total. The fractional value would have been 11/60th. Let's look at the rectangle, the slide. What's the area of the slide? What area does the slide take
I'm
up?
seeing 21, 21.
21 would be correct. What about the monkey bar?
9, 9,
That
9.
is correct. What about the trapezium?
I'm seeing 18. 18 or 19. 18 or 19. 19.
19 would be correct. All right, boys and girls. So to part E. So you're supposed to show that all the parts add up to one whole. How can we do this? How can we show that all the parts add up to one whole? What will we be using?
I'm seeing other responses in the chat than what is asked, Mr. Lewis. I'm asking the students to be mindful. Somebody is saying addition.
Addition, what
Jamiris
are we
is
adding?
addition, length. Somebody went as far as to say length times width.
All right. So we're looking at, remember, the question is how
They said add all the
to,
fractions.
yes, add all the fractions. So let's look at it. So for the first orientation, we had a rectangle, which was represented 20/60th. The triangle represented 6/60th. The square represented 16/60th. And the trapezium represented 18/60th. Could you quickly go ahead and calculate and tell me what is your result?
Not seeing any response. I'm seeing 60/60th.
Seen any other response?
60/60. That's the dominant answer.
All right, good job, boys and girls. It have indeed been 60/60th. So, and 60/60th would be the same as one whole. Let's look at a different orientation. So, one had the rectangle at 21/60ths, the triangle at 11/60ths, the square at 9/60ths, and the trapezium at 19/60ths. Could you tell me what is the result of this equation?
They're still saying 60/60th.
Dominating?
Yes.
Good job, boys and girls. It's indeed 60/60th, which is equivalent to one whole. So based on the survey of the children's most favorite and least favorite activity, do the size of the shapes for their design meet the children's needs? Based on the survey of the children's most favorite and the least favorite activities, do the size of the shapes for your design meet the children's need?
I'm seeing yes. Yes is dominating the chat.
All right. So let's look at it. So we'd have had the 60 square units. So let's observe what is here. So let's see if we would meet. So the seesaw is 3, the slide is 10. We are seeing where the seesaw is 668, which is good, and the rectangle is 20. Good job. So yes, the number of squares covered in the design for the rectangle, which is the slide, which represents the slide, is the greatest, and the number for the triangle seesaw is the least. Excellent job, boys and girls. So let's look at this and tell me about it. Is the number of is the area for the rectangle greater than the triangle? The responding is
They're saying yes, it is. Yes, it is.
great. So let's look. Is the triangle the least? The seesaw the least in this representation?
They're saying no, no.
All right. Good job. Good observation. So if we look at our shape, so yes, the slide is 10. The seesaw is less than that. So no in this case, because the number of squares covered in the design for the rectangle slide is the greatest, but the number for the triangle or the seesaw is not the least. Instead, the square or the monkey bar is the least. Now, boys and girls, here are some tips and some reminders for you. So ensure you read the prompt and instructions carefully. Always think of what goal you need to meet for each part of the task. You will sometimes need information from the previous section. Check the reasonableness of your answer for each part of the task. Check that you have attended all parts of the task. Now, boys and girls, are there any questions? No questions? Well, boys and girls, it was a pleasure sharing with you this afternoon. All the best. We wish you all the best for your exams.
All the best, boys and girls. Have a good evening. Thank you for joining us.